Okay, so there are a lot of normal distributions in the world, but they're always defined by two things. The mean, which is our x with a hat on it, the middle of our normal distribution. The other thing is the standard deviation. Now, what's the standard deviation? It's a measure of spread. That is, it determines how spread out our distribution is. So let me give you two quick numerical examples of this. Okay, so here's two classes. This is class A and this is class B. Maybe they're maths class or English classes. Now this is the results from a recent test. Now the first class, you can see the middle number is about 8. So there's our mean. But the lowest is 6 and the highest is 10. They're not that spread out. They're only, the highest is 6, lowest is 10. There's a difference of 4 there. Look at number B though. In this case, the middle score is 5, but more importantly, the measure of spread is large. The lowest is 0 and the highest is 10. Okay, so this is really spread out data and this is less spread out data. That means that the standard deviation of this one is going to be lower than the standard deviation of this one. Standard deviation of this one, low. Standard deviation of this one, high. Now the way to calculate standard deviation is complicated. It's too complicated for this video. But basically it's finding the average distance from each point to the median. Doesn't matter though. What matters is how many people are in a standard deviation. This is how we're going to define standard deviation. Okay, so I'm going to go over here and I'm going to draw a line from here, this point here, to this point here. I'm going to colour all of that in. Okay, all of the people that are in there, this is one standard deviation. Standard deviation, we use this symbol for standard deviation, a little 0 with a line coming off it. Okay, so standard deviation, one standard deviation to the right and one standard deviation to the left. Now, how many people are in that standard deviation? Well, it turns out that 34% of people are one standard deviation higher than the mean. And 34% of people are one standard deviation lower than the mean. This never changes. Okay, one standard deviation higher, one standard deviation lower. Now, if I move further away, and I go 2 standard deviations away from the mean, and we add all of that up, we end up with altogether, from this side to this side, 95% of people are either 2 standard deviations higher than the mean or 2 standard deviations lower than the mean. That means that almost the entire population, 95 out of 100 people, are within that. Now, if I go even further, that should sort of come down a bit more like that. If I go even further there, 99.7% of people are within 3 standard deviations of the mean. That means that only 3 in every 1,000 people are either higher or lower than that. So it's very, very, very unusual that someone's going to be 3 standard deviations higher or smarter or heavier than the general population. And it's very, very unlikely that someone is going to be more than 3 standard deviations shorter or skinnier or dumber than the mean. So there's our standard deviation. It's a measure of spread. Now, normal distributions can all look different. So we can have a normal distribution that looked like this. Now, this normal distribution has a very small standard deviation. Okay, you can see this one is probably kind of like group A here. If we drew group B as a normal distribution, it would look more like this. Okay, and so you could see that this one is nice and big and spread out, whereas this one is not as spread out. All right, so there's our normal distribution, the standard deviation. It's a measure of spread. We use this symbol, and together with the standard deviation and the mean, that's how you define a normal distribution.